How are Python objects implemented at a C level? Imagine building a house where each part has a specific role, and everything fits together perfectly. That's kind of how Python objects work behind the scenes. When you write Python code, you're creating objects that store data and perform actions. But how does the computer keep track of all these objects? The answer lies in how Python, specifically the CPython implementation, builds these objects using C language structures. At the core, every Python object is represented by a structure called PyObject. Think of PyObject as a blueprint that describes what all Python objects have in common. It's a C structure that contains two main parts, a reference count and a pointer to the type of the object. The reference count is like a counter that keeps track of how many times the object is being used. When this count drops to 0, the object is automatically cleaned up and removed from memory. The type pointer points to another structure that describes what kind of object it is, like a number, a string, or a custom class. This setup makes Python very flexible. When you create a new object, such as a number or a string, the interpreter allocates memory for it and sets up a corresponding PyObject structure. For more specific types, like a class instance, the structure starts with the PyObject as its first part. This way, the system can treat all objects uniformly, even though they might have different data and behaviors. It's like all vehicles share some basic features, but also have their own special parts. Python's object system in C also supports inheritance and polymorphism. This means you can create new object types that inherit features from existing ones. These new types embed the PyObject structure at the beginning, then add their own data and functions. When Python runs your code, it uses the type pointer to decide how to handle each object, whether it's calling a method or accessing an attribute. This design allows Python to imitate object-oriented features like inheritance and method overriding, even though C itself doesn't have these features built in. So, when you create an object in Python, the interpreter sets up a PyObject in memory. It then uses the type pointer to figure out what to do when you call a method or get an attribute. This system keeps things efficient and flexible, letting Python be a high-level language with a dynamic object model built on a solid C foundation. Understanding this helps explain how Python manages memory, handles object lifecycles, and supports its rich object-oriented features.